So welcome back. It's so good to have you here again. Welcome back to the channel Pendulmatics, where we break down mathematics and make it easy and fun to learn. I'm Pendulum. I'm your tutor on this channel, and it's a pleasure to have you back. Alright, so welcome. If you're new to this channel, please consider subscribing and turning on the notifications button. Ring that notifications bell so that whenever we make a new video on mathematics, you'll be notified to come and watch and learn. Alright, so welcome. We are still on set theory. We are making progress. Today we'll be looking at two set Venn diagram problems. Alright, so Venn diagram problems that have to deal with two sets. Okay, so we have 3 questions on the board already. I'm going to treat in this video. Like I always say, I take enough or ample examples so that you really understand whatever topic we are treating. Alright, so as we go into the video now, please do well to like the video, drop your comments on it, let me know what you think about it and if it was helpful to you, and share the video. That is very important. So share it everywhere you can to as many people as you can so that it will help them, because like I said, so many people struggle with sets, especially Venn diagrams, and this could really help them. So if you have a friend, a colleague, a child who is preparing for WAEC, junior or senior, let them have this. Alright, so let's look at those questions quickly. They are not difficult. Okay, 2 set Venn diagram problems are not difficult. 3 set Venn diagram problems are more cumbersome. So we'll be looking at that next, but let's do this first. So we are told that 25 students were asked about their extracurricular activities. 16 of them say they play basketball, 11 say they play football. We're asked to find out how many students play both sports. So our universal set, that is the total number of students, is 25. People that play basketball, 16. Those that play football, 11. We have to find out how many people play both. So we have to find out the number in basketball intersection football. That's what we are looking for. So let's call that X. Alright, so what do we know? I always tell people when you are solving a question, especially in mathematics, start from what you know, list out all you know, and then work towards the unknown. We know that the universal set, the total number of students is 25. Those who play basketball, they are 16. Those who play football, they are 11. And then you have to find people that play both. That is the number of students in B, basketball intersection football. So we call that X. And if I draw this in a Venn diagram, I have that my U here is 25. Okay, now I have 2 sets. The first set is basketball, which is 16. Then I have football, which is 11. We have to find X. Okay, so if you look at this, X is the intersection. That's the number that play both football and basketball. Now, if this whole first set is basketball, that is 16. Alright, this first set, and the intersection, this part, is X. What will be this remaining part? By common sense, this should be 16 minus X. It's simple. If this whole thing is 16, you are told that this whole thing is 16, but then a portion like this is X. A part of this whole circle is X. So what will be this remaining part? It's just the whole circle 16 minus here. Alright, so that's how we got 16 minus X here. The same thing for the other side. If this whole set F for football is 11, and this part of it too is X, this remaining part will be 11 minus X. And if you're able to do this, then you have solved this question almost to the end, because what is left here now is to just bring out your equation. And once you're able to do this, you fill out this part. This part here is basketball only. That's what we call it. Basketball only. 16 minus x. This part is football only. 11 minus x. Then x is basketball and football. So what you do is to add up this plus this plus this is equal to the universal set. Alright, so the number of items in basketball only plus the number of items in football only plus the number of items in both of them will give you the universal set. Alright, so what this means is that U is equal to number of items in basketball how do I write this now? Okay, let me write basketball only plus number of items in football only plus number of items in basketball intersection football. Alright, so what I said, if you add this basketball only plus football only plus their intersection will give you your universal set. Alright, now for this case, so let's go on. Our universal set is 25. Now basketball only is 16 minus x. Football only is 11 minus x. 11 minus x. Then the intersection which we don't know is x. Okay. Now if we go on, 25 is equals to, now I can okay, let me rearrange this. 16 plus 11, then minus x plus x. If I rearrange this side, okay, 25 is equals to 16 plus 11 should be 27 minus x plus x will cancel out, so these two will cancel out. Minus x plus x is 0, so I'm only left here with minus x. Now if I collect like terms, this minus x will cross to this side, 25 will cross to this side. Okay, I want to bring the like terms, so these two are like terms, I want to bring them together. So I can bring minus x to this side, and when minus x crosses, it becomes x. And I can bring 25 to this side, and when 25 crosses, it becomes minus 25. Remember, when any number crosses, the sign will change. So if I collect like terms here, x will be equals to 27 minus 25, and x is equal to 2. So we have that the number of elements in basketball intersection football, x, is equal to 2. So 2 students play both sports. Alright, 2 students play both sports. That's the answer to this question. So it's very simple. You know that this is 16, the whole of basketball, the whole of football is 11. All you need to find out is basketball only and football only. And what you do, subtract the intersection. So that's why we get 16 minus x, which is the intersection, and 11 minus x. Alright, so then to get your answer, if you add this up, add this up, add this up, you get your universal set. Alright, remember in this case, they didn't tell us that there is any student that doesn't play either of the sports. So that's why we don't use it. But in this case, we are going to need that. So let's look at the next example. I hope this is clear. It's quite straightforward. Now in this example, there is a slight difference, because here now they said in an examination of 40 students, so our universal set is 40, the total number of students. 20 wrote chemistry, so chemistry students we have 20. 15 wrote economics, Economic students, we have 15. How many students took neither subject if 5 took both? So we know that 5 students took both. So number of elements in chemistry intersection economics, that's both, is 5. And then it says how many students took neither. So that's going to be number of elements in chemistry union economics complements. That's what we are looking for. Okay, so how many students took neither of the subjects? That's how many students are not inside the set at all, inside both sets. So if I draw the Venn diagram for this, I have something like this. Now I have chemistry, I have economics. Chemistry, 20 students. Our universal set is 40. That's the total number. Chemistry, I have 20 students. Economics, I have 15. Alright, then they told us that 5 students took both. So the middle here is 5. That's the intersection, 5. And then how many students took neither? That means they didn't take chemistry or economics. They are part of that class. So they are inside the universal set. Pay attention. Those students that took neither subject, they are still part of that class. So they are inside this universal set. This rectangle is universal set. So they are inside the universal set. They are part of that class. But they did not take chemistry or economics. So they are not within these two sets. So they are going to be outside here. So that's this. So I can just put them here, X. Alright, so we are looking for the number of students outside these two sets, but they are still within the universal set. Alright, because they are part of that class. That's why they are still here, although they did not take chemistry or economics. So they are outside these two sets, but they are within the class. Alright, now following the same logic here, if 20 students took chemistry, okay, and 5 students took both chemistry and economics, if I asked you to now find out how many students took chemistry only, how many took chemistry only, that's going to be 20 minus 5. 20 minus 5. 20 took only chemistry, and then 5 took both. So how many people took chemistry only? 20 minus 5, that's 15. And for this side, how many people took economics only? That will be economics is 15 minus the intersection, that's both, 5. That will give you 10. Alright, so again here, our universal set is number of elements in chemistry only plus number of elements in economics only plus number of elements in the intersection chemistry intersection economics. That's this plus this plus this. The same thing we did here. This plus this plus this. Add up everything inside the set. Add up everything inside the set. The simple way to think of this is add up everything inside the set plus everything outside the set is equal to universal set. Everything outside the set is not this, so please. This one, that is the one for neither. So if you add up everything within the sets plus neither, you get your universal set. So here you're going to add number of elements in C union E complement. Alright, so this is actually the full way or the full formula for solving Venn diagram sets. So you can copy this down somewhere. Okay, you can copy this down somewhere. You can copy this down. Number of elements in the first set only plus number of elements in the second set only plus number of elements in their intersection plus number of elements in neither of them. Alright, if you want to write it down like that. So the universal set is equal to number of elements in the first set only plus number of elements in the second set only. And how do you get those ones? The whole set minus the intersection will give you that first set only. The whole set minus the intersection will give you the second set only. Please, this thing is simple if you understand it. All right. So the universal set is number of elements in the first set only plus number of elements in the second set only, then plus number of elements in their intersection, plus number of elements in the intersection, plus the number of elements in neither of the two sets. If you can get that, remember that, write it somewhere, you're good to go. All right. It's even the same thing for three sets, just that you will now have it, instead of it to be 4, it will now be like 8 because it's three sets, but it's the same logic. Add up everything inside the set plus whatever is outside, that is neither, is equal to your universal set. If you have this knowledge and you can remember it, you won't have a problem with sets. Again, I repeat, add up everything inside the sets. Everything inside the sets. So both the ones that are only, the ones that are the intersection between two sets, and then the one outside, neither. If there's a neither in the question, some questions may not have neither. So if there's no neither, you assume that this is 0, which doesn't change anything. But if there's a neither, you add it up and you equate it to a universal set. That's just it. So in this case, our U is 40. I'm taking time to explain this because if you get it and you understand it like this, no matter the set they give you, it's just a question of being careful as you apply this. You will get your answer. Alright, so chemistry only is 15. No, yes. Then economics only is 10. The intersection of chemistry and economics is 5. And then neither, that's what we are looking for. Neither chemistry nor economics. Now this one is very simple. 15 plus 10 plus 5 is 45, right? No, it's 30. Sorry, 30 plus x. So I collect like terms. I'll bring this 30 to this side. And when 30 crosses to this side, it becomes minus 30. So 40 minus 30 is equal to x. 10 is equal to x. So in this question, or for this question, 10 students did not study either of the subjects. 10 students did not take chemistry nor economics. I hope you get this. It's very simple, please. Very, very simple. Let's look at the last one, and I'll give you an assignment. I will wrap up this video. Next video, we'll look at 3 set problems. That video I may have to break it into 2 and make 2 videos on it because 3 set problems, they are more bulky. So I want to take enough examples and have enough time to explain them. So I may make 2 videos on that. But let's look at this. In a certain class, 12 students offer science subjects. So science subjects 12. 10 offer arts. Okay, let me just use S. S is 12. Arts. Then 10 students offer arts. Then they say 2 students offer neither. Neither. So how do I write it? Let me just write neither, maybe to make it clearer. 2 students offer neither. That's outside the 2 sets. And then 4 offer both. So both. Let me write it like this to make it clearer for you. 12 offer science, 10 offer arts, 2 offer neither, and 4 offer both. The question is how many students are in that class? So you're asked to find the universal sets. How many students are in that class? So if you draw your Venn diagram, you have that science, we have 12 students in them. Arts has 10 students. We don't know universal set. Then 4 offers both and 2 offers neither. Okay. So now if 12 students offer science and 4 offer science and arts, that's meaning of both. Both means and. 12 offer science, 4 offers science and arts. And then you're asked how many people will offer only science. Remember, you must find that out first. How many people offer only science? That's here. Like we've been doing, 12 minus 4 will give you 8. Okay. Then 10 offer art, 4 offer art and science. How many people offer only art? 10 minus 4, 6. If you've done this, you're home free. You're home free. Because remember our formula, the universal set is equal to number of elements in science only plus number of elements in arts only plus number of elements in both. Let me write it like this, maybe plus number of elements in neither. Alright, so maybe this is easier for you. Number of elements in science only plus art only plus both plus neither. So if we substitute our values, you can write this formula too if it's simpler for you, both and neither, if it makes it clearer. So we're looking for u. Science only is this 8, art only is this 6, both is 4, neither is 2. This one is the easiest of all. 8 plus 6, 14, plus 4, 18, 20. So 20. So there are 20 students in that class. As easy as selling pie. In fact, this may even be easier than selling pie. So I believe with this, you should be well equipped when it comes to two-set Venn diagrams. We've looked at the question where you're asked to find both. How many students study both? We have looked at the question where you're asked to find how many students study neither. Okay, it may not only be study subject, it may be anything. How many people play this sport? How many people speak this language? How many people do this? But we've looked at the case of both, we've looked at the case of neither, and we've looked at the case of the total number, the universal set. So between these three examples, you should be well grounded in two sets Venn diagram problems. Okay, so let me give you an assignment. I'll give you an assignment and then we'll be done. Okay, so here you have your assignment. There are two assignments this time. So this one, the first one is similar to what we've done. In a class of 80 students, 65 studies English, 50 studies mathematics. If both subjects were compulsory for all students, what this means is that there is nobody that studied neither of the subjects. Both subjects are compulsory, so there is no student who took neither of the subjects. How many students studied both subjects? That we are asked to find. This one is quite simple. Then this is a slightly different type of Venn diagram problem. The Venn diagram below represents the universal set of integers and its subset P and Q. So this is a Venn diagram. We have subset set P, set Q with numbers inside. It has to list the elements of P intersection Q, P union Q, P union Q complement, P intersection Q complement, Q intersection E, the universal set, and P union E. Now, because of this example, saying that I've not really done something like this, that's why I want to do example 4 for you, because it's not fair to give assignment or classwork for something you've not done. Alright, so let me quickly do this so that you can follow this example and do this assignment. Now, we have a similar question. The Venn diagram below represents a universal set E of integers and its subset A and B. Now, we're asked to list the element of the following set: A union B, A intersection B, A intersection E, the universal set, and B union A. So, I'm doing this not because it's difficult, but just let it be that I did it before asking you to try it as an assignment. So first of all, we have the number of elements in A union B. That's the first thing we have to list out. Okay, we have set A, we have set B. You can first of all decide to list out all the elements in set A. Okay, but I don't think you even need to waste all that time. A union B means everything in A and everything in B, right? Without repetition. So everything here is A union B. All the elements here, everything together is union, the combination of the two sets. So A union B is going to give us, I'm write it in order, although the order doesn't matter, but it's just nice to write it in order. So you have 2, 2, 3, 4, 6, 7, 8, and 10. Alright, so everything inside here. So that's 2, 3, 4, 6, 7, 8, and 10. Very simple. That's union. Then you have intersection A intersection B. Elements of A intersection B. This one is very clear from the Venn diagram. A intersection B. Intersection means what is common to both of them. So we only have this is intersection, this middle, and there are only two elements here, 3, 7. Quite straightforward. Then you have number of elements in A intersection E. Okay, so what is common between the elements of set A and the universal set? Now take note that A is a subset of the universal set, meaning that everything in A is also in the universal set. Alright, so what is common between A and the universal set is everything in A. It's just like you're asked what is common between Lagos and Nigeria. Everything in Lagos is also in Nigeria because Lagos is a subset of Nigeria. Lagos is in Nigeria. So everything in Lagos is in Nigeria. So what is common to Lagos and Nigeria is Lagos as a whole. What is common between A and E, the universal set, is the whole set of A, because everything you find in A, you also find it in E, the universal set, because A is a part of E or is a subset of E. So everything in A is common to A and the universal set. So 2, 3, 7, 8, 10. 2, 3, 7, 8, 10. Everything in A. Alright. And then 4, what is common to the number of elements in B union E? Now again, most of these things is just common sense. Now B union E. B is a subset of E. B is within or inside E. So if we say what is the union of the two, that's a combination of the two of them. If you bring everything in E, everything in B, they are also part of E. Alright, so if we are taking the union of this, remember without repetition, it's just the same thing as taking everything in the universal set. Alright, it's just like taking, if you decide to bring out everything in B, you have 3, 4, 6, 7, and then you bring out everything in E, you have all the numbers here, 1, 2, 3, 4, 6, 7, 8, 5, 10, and 9. Everything in E union everything in B. Let me bring it out so that you see what I'm saying. Maybe let's not do mental math. Now everything in B is 3, 4, 6, 7. That's everything in B. While everything in E, that's the whole set there. All the numbers here are in E because E is the universal set. So we have 1 is outside. Then we have 2, 3, 4, 5 again is outside. It's outside the two sets, but it's within the universal set. Then we have 5, we have 6, we have 7, we have 8, we have 9, we have 10. This is everything in the universal set. So you have to find what is the combination or the union of these two. Of course, it is just this, it is E, because everything here is also here. We have 3, we have 3, we have 4, we have 4, we have 6, we have 6, we have 7, we have 7. So everything in B is also in E. So the union of these two sets is what? the universal set is E. Okay, remember, no repetition, won't talk of union. So the union of B and E is just everything in the universal set. Everything in the universal set. Okay, so from this, take note that the intersection of a set and the universal set is that set. Write that down. The intersection of a particular set and the universal set gives you that set that is being intersected with the universal set. So A intersection E gives you A. B intersection the universal set gives you everything in B. Alright, so the intersection of a set and the universal set gives you that set, all the elements of that set. Whereas the union of a set and the universal set gives you the universal set. Alright, so the union of set B and the universal set gives you the universal set. Set A and the universal set, their union gives you the universal set. Alright, so with this, I believe we are well versed and grounded in two set Venn diagram problems. Alright, so if you didn't understand it, you can always ask your questions in the comments or send it directly to me on WhatsApp or drop it in our Telegram community. The link to the Telegram community and to my WhatsApp is in this channel's description. Please make use of it. I put it there because of you. Alright, if you found this video helpful, then please do not forget to like the video and share it with your friends. Share it on your WhatsApp status, on your Facebook, everywhere. Let us help someone who is struggling with this topic. Alright, in the next video, we'll look at 3 set problems with 3 set Venn diagram problems. But until then, please keep crushing mathematics, keep studying, and keep doing your best. And I'm very sure you triumph over the monster that is seemingly mathematics. So thank you so much.